Okay, 1986, question AB6. It says a shaded region R shown in the figure above is enclosed by the graphs y equals tangent squared x and y equals 1/2 secant squared x and the y-axis. Part A says find the area of region R. So this is our sketch. The top curve is 1/2 secant squared and the bottom curve is tangent squared. This is shaded region R. So we're going to have to do an integral. First, we have to find our intersection points. So set the two equal to each other. We have this trig identity that says secant squared x is equal to tangent squared x plus 1. So we set up tangent squared x is equal to 1 plus tangent squared x over 2. If how did I do this? So that gets us to tangent squared x equals 1. And so you get x equals pi over 4. So your integral is going to be from 0 to pi over 4 of the top curve minus the bottom curve dx. So integral from pi over 4, secant squared x over 2 minus, so then we manipulated this to get it to secant squared x minus 1 dx. Simplify it down even further. 0 to pi over 4, 1 minus secant squared x over 2. So then we integrate this and we get x minus tangent x divided by 2, evaluated from 0 to pi over 4. When you do that, you get pi over 4 minus 1/2, and you shouldn't have to simplify any further than that. The formula for the washer method is pi r squared, big R for the big radius, minus pi r squared, little r for the little radius. So to find volume of that, we're going to do pi. We can bring the pi out front since it's common in both of these. Bring the pi out front, do the integral from 0 to pi over 4 of your big R, which is secant squared over 2. Square that, you get secant quadrupled over 4 minus tangent to the 4th x, and that's all you have to do because it says do not integrate.